200 years ago, we lived in extreme poverty. We had very little medical knowledge, and as a result, our average life expectancy was 32 years. And 100 years went by, and very little progress happened. Life expectancy is at 34 years. And this continues on until the year 1918, when life expectancy actually drops to 23 years. Initially, I thought this was an anomaly in the data, but it turns out to be the impact of the Spanish flu. The Spanish flu infected 27% of the world's population, killing between 50 to 100 million people. And this is an insight that is very relevant to our world today and serves as a reminder of how devastating a global pandemic can be. But the Spanish flu is followed by the discovery of penicillin, the production of antibiotics, and by the 1960s, average life expectancy jumps to 55 years. But this masks a huge global health inequality, where countries such as Norway have life expectancy in the 70s, where other developing countries such as Sierra Leone have life expectancy in the 30s. And this brings us to today, and let's just take a moment to celebrate the amazing journey we have gone on. Life expectancy is 73 years, and the health inequality gap around the world is narrowing, with the biggest improvements taking place in the developing world in the last 50 years. In the US, we can see that average life expectancy is at 79 years. And if we select the US, we can uncover some insightful local trends, such as this fall in life expectancy during the Civil War. So what happened in these last couple of decades that has improved life expectancy so much? Well, one really important factor to consider is child mortality. In this chart, we are comparing life expectancy to child mortality. And we can clearly see that countries that have higher life expectancy rates also have lower child mortality rates. But just 30 years ago, we had countries where 1 in 3 children were dying before the age of 5. So let's take a look at how things have actually changed in these past 30 years. Now, as our dots start to move, take a look at Rwanda here that saw this awful increase in child mortality rates caused by the Rwandan genocide. But generally, the trends are for the positive. We're seeing countries starting to reduce their child mortality rates, increase their life expectancy. We see another anomaly here that was actually caused by the Haiti earthquake. But in a matter of 30 years, we see countries are able to reduce their child mortality rate from 1 in 3 to 1 in 10. And I can now start drilling into individual country journeys. So let's take another look at Sierra Leone over here, where we can see child mortality rates have reduced massively. During the same time period, we can see significant improvements in GDP per capita and immunizations rate, helping us piece together the transformation the country went through. Building a visual in Power BI is as simple as asking a natural language question. We're going to start by looking at life expectancy by sex and adding a visualization to the page. And we're going to add another one, looking at life expectancy by year. Power BI automatically figures out the most appropriate visualizations for my questions, which is a bar chart and a line chart. So let's add some enrichments to my line chart and try and predict how long people are going to be living by the year 2100. It's very easy for me to add a forecast to this visualization. I can choose how many points I want to forecast into the future. I can choose things like my confidence intervals, whether I want to apply seasonality, and I can just add this enrichment to the visualization. And we can see by the year 2100, we're going to be living to almost 90 years old. But because I was able to build these visualizations so quickly, I'm actually going to add another visualization. And this time I'm going to add an AI visualization to the page, which is going to help me do key driver analysis. Now we have hundreds of metrics we could be analyzing in this data set. So we're going to be focusing on our socioeconomic factors. And the question we're going to be asking is what actually influences life expectancy to increase? Now, every time I drag in one of these factors from my data set, we're actually running a machine learning model behind the scenes. And every time another factor gets added, we're actually rerunning this model, throwing away the old one and calculating a completely new one from scratch. So as we add these factors, we can see the top factor that comes up is safe drinking water. When more people have access to safe drinking water in the population, our life expectancy increases. But what if we're only interested in the female population? Well, I can simply select females in my bar chart over here, and the whole machine learning model just runs from scratch. Now, when it comes to females, my top factor is actually education. As the percentage of females who goes to school decreases, so does the life expectancy. I can also look at drivers at a country level. All I have to do is type in a country name, such as Great Britain over here, and now we're going to rerun the whole model just for Great Britain. And here we can see the top factor is actually GDP per capita. As GDP per capita increases, so does life expectancy. But what if I want to do some variance analysis? For example, I might want to take a look at where life expectancy increased the most since 2010. The decomposition tree in Power BI enables me to break down any metric I want in any order. So I can start by breaking things down by continent, and I can very quickly see that life expectancy increased the most in Asia. But what actually drove this increase? And here we have a lot of different factors to consider, and I might not be sure where I should be looking. And here the AI in Power BI can help me figure this out. I can simply ask Power BI where this increase is coming from, and Power BI is going to analyze all of these factors and tell me that countries in Asia that saw significant decreases in maternal mortality saw the largest increases in life expectancy, a growth of 7.56% on average. In the case of Africa, the AI reruns and tells us that the increase in life expectancy was associated with a decrease in malaria cases, whereas for Europe, it was to do with an increase in GDP per capita. And I can keep going down and doing this root cause analysis, asking Power BI to keep finding the high values for me. And at any point, I can drill into this path and actually see which countries fall into this segment. In this case, we can see all our Southern and Eastern European countries come up. These are all important insights that I want to be able to share with my team. I can simply save these as bookmarks with annotations that contain my conclusions that I can go ahead and present at my next team meeting. I can even bookmark more complex things, such as paths inside my decomposition tree, as well as data selections. So here I have a website full of awesome flag data that I want to use as a data source. The only problem is it's not in a nicely structured table, so it's not easy for me to pull this. Luckily, we also have AI for data prep in Power BI that can help. So the first thing we need to do is connect to some data, and Power BI has a ton of connectors, all the way from Access Database to Zucchetti HR Infinity. What we actually want to use over here is our web connector. So the first thing that we need to do is we need to connect to our flag website. So as we've established, we do not have a nicely structured table. So what we're going to do instead is we're actually going to add this data using examples that we can just give to Power BI. And Power BI will just figure out this data. First thing I'm going to do is give this name a column. And then we're just going to give Power BI a couple of examples. So we're going to type in Afghanistan, we're going to type in Albania. And here we go. Power BI just figures out the rest. Let's do another one. Let's maybe do population. Over here, again, we're going to type in the first example that we see under Afghanistan. And now Power BI just needs simply one example to figure this out. I don't have to go in order. I can skip a couple. I can go into density, type this one as well. And again, Power BI just figures these out. It has never been easier to scrape data from the web. Now I'm just going to wait for this table to load up, and we have this data. But it's still not looking super clean. What I really want is my country name to be in a separate column. So again, I could use the hundreds of out-of-the-box functions that we have inside Power BI, but I'm just going to add a column from example. And I'm going to type in Afghanistan over here, and Power BI just figures out I don't want the country code. And I can just add that as a column. Now we see over here a nice preview of the distribution of my data, if we have any blanks or errors that might be there. And just like I was able to add this qualitative field, I can also really easily manipulate my quantitative data using examples. So over here, we have our life expectancy column. And then what I want to actually do is split it up into ranges. So instead of having 81, I want it to be between 80 and 85. And again, Power BI just figures out, here we see 79, 75 to 80. It figures out the pattern that I want. For joining files, I can easily join them over here, and I can specify which tables I want to join, which columns do I want to join them on, what kind of join I want to do, and whether I want to do things like fuzzy matching if it's not going to be an exact match. But I don't need to flatten everything out. I can keep my data in a star schema, and Power BI gives you a complete semantic model with relationships, hierarchies, and calculations. You can even auto-detect relationships based on the columns and the underlying data. With Power BI, I can of course subscribe my business users to a regular newsletter about their data, or I can set up alerts for notifications when their data crosses a particular threshold. However, all of my business users spend their day within teams, so to truly maximize productivity, we need to bring the data to the users. So instead of accessing all of my Power BI content in the web, we now have a fully integrated and rich app experience built into Teams. And here I can access my reports, my dashboards, consume content, and even set up alerts. But I can also simply collaborate on my data directly inside my Teams channel where the rest of the group works. Here I have shared a Power BI report, which is just shown as another tab inside my Teams channel. And this is not a screenshot of my data. This is a fully interactive Power BI report. This makes it super easy for me to consume and discuss the data, as well as address any comments that I have been tagged in directly in Teams without any context switching. Now we can see that this report has some important metadata telling us that this is confidential data restricted to my organization. This is because Power BI uses Microsoft Cloud App Security and is fully integrated with its information protection capabilities. Now to do some further analysis of my data for the Surgeon General, I may want to work with my data in Excel. Now when I export out this data to Excel, you're going to see that the sensitivity labels get passed through Power BI, through Teams, all the way to Excel. My data is now encrypted, meaning if I leave the data on a USB stick or I leave the organization, no one would be able to access it. Finally, what if my business users just want to do some quick ad hoc analysis in Excel? Well, Excel now has an inherent built-in understanding of Power BI organizational entities. So the Surgeon General can simply tell Excel that he wants these countries to be treated as organizational data, and look what happens. We were able to automatically create these organizational entities, and I can even see this Power BI entity card that describes all the data for me. Now I can very easily pull this data into a table and even create some quick comparisons looking at things like life expectancy or GDP per capita. If I want to add another country, I can just simply type that in, and Power BI takes a second to look at this data and pulls it in from the data model as well. And this isn't a pivot table, so if I want to just edit these cells and maybe do things like format this into a currency, or even more complicated things like typing in a formula, where we're going to pull, let's say, the population, maybe we can multiply it by the GDP per capita, and create our own calculations on top of this data. And this is all live connected data to Power BI, so I can simply refresh it, and if new data came in, all of these numbers would update. A top focus for Power BI has been storytelling and improving the data literacy of every user. And for this reason, it is now as simple as right-clicking a visualization and asking Power BI to summarize it to get all the top insights that we need. Power BI is going to automatically analyze the data and generate a summary for me. Here, for example, we are looking at time series data. So Power BI automatically carries out trend analysis, highlighting that the longest period of continued growth occurred in North America, where GDP grew over $15,000. Europe, on the other hand, had more spikes and dips in the data. So we just highlighted the last 3 years, where we saw an increase of GDP of almost 12%. But what if I wanted insights like these for the whole report page, rather than just focusing on a single visual? Well, I can simply add the Smart Narratives visualization, which is going to automatically analyze the whole report page, figure out everything that's going on that's important, and just generate an automatic narrative for me, summarizing everything that's going on. And this summary is fully customizable. So if I want to go ahead and maybe change around things like make some things bold or change the colors, I can really easily do that. It's just like making edits in any text box. And not only can I change the formatting over here, I can even add my own custom summaries as well. So if, for example, I want to type something like average life expectancy since the year 2000, I can just type that in. But now I want to actually create a dynamic value rather than just inputting a static number. So what we've actually done is instead of having to write DAX to create your complex calculations, you can just simply leverage Q&A and use natural language. So what I'm going to do now is I'm going to simply type in average life expectancy since the year 2000, just in natural language. And Q&A, instead of generating a visual, is actually going to just generate a value for me. Do this complex calculation, and I can just save this directly inside my visualization and have it automatically get calculated, truly democratizing creating calculations for everyone. And this summary is of course fully interactive with the rest of my report as well. So for example, if I want to just focus on insights about Europe, I can just select Europe over here, and my visualizations are going to cross-filter, but so does my summary. And this applies to both the automatically generated summary as well as any additions that I've made, including my dynamic values. If I want to, for example, do a comparison of Europe versus North America, I can just select both of these, and my automatically generated summary is just going to do this comparison for me. It's never been easier to do storytelling with your data.